In the last video, we finished part C of example 2, and this was the conclusion that we reached from that part. We completed the 99% confidence interval, and we got this result. 0.3578 was the lower bound, 0.4472 was the upper bound, and that was a 99% confidence interval, meaning that we're 99% confident that the proportion is somewhere between 35.78% and 44.72%. Part D is going to refer to that result we just got. It asks, is it possible that a majority, more than 50% of households in San Bernardino County, that a majority are multi-generational, and is it likely? Well, on the one hand, it is possible that P is more than 50%. We have 99% confidence that P is between 35 and 44%, but it's 99% confidence, and that means that there's a 1% chance that P is some other percentage not between 3.78% and 44.72%. So there is a small chance that our interval is incorrect and the actual value of P is some other number outside the interval. But that's very unlikely. It's unlikely that P is more than 50% and unlikely that P is anything outside of this interval because we have really high confidence. We have 99% confidence. So the point is, when you have a confidence interval, your result is never certain. But the best you can do is to have high confidence that your result is a good estimation. Part E is very similar to Part C. It's asking that you construct and interpret a confidence interval, and the only difference is that now they want a 90% confidence interval. All of the calculations are going to be the same. In fact, in the notes, it's all the same notes and same formulas and calculations. The only difference is that now everything will be in terms of 90% confidence. With 90% confidence, when you calculate the critical Z value, now it's going to be 1.645 for 90% confidence. And you still plug it into the formula. Now you have a different margin of error of 0.0285. Take all of those same steps, calculate the confidence interval, and it comes out to 0.374 is the lower bound, 0.341 is the upper bound. And it's similar for when you work this out on a graphing calculator. All the same steps. The only thing that will be changed is the fact that now the confidence is 0.90 for 90%. And so here's the interpretation of that particular confidence interval. But I'm going to go on to part F. Part F says, when the level of confidence is decreased, what happens to the confidence interval? So in part C, we calculated the 99% confidence interval, and it was 0.3578 for the lower bound, 0.4472 for the upper bound. In part E, the 90% confidence interval was calculated, and it came out to 0.374 for the lower and 0.431 for the upper bound. And so what's happening is that this interval is more narrow. Its width has decreased, and that's always going to be the case. When you decrease your level of confidence, your interval becomes more narrow. And when the width of your interval decreases, when it becomes more narrow, another way of saying that is that the confidence interval becomes more precise, which is good. As a researcher, you'll want to strive to have confidence intervals that are precise, that really narrow down what your estimate should be. Part G asks, what are two ways to improve the precision of a confidence interval? Well, two ways to do that would be to either decrease the level of confidence. Just what came up in Part F is that fact right there, that if you decrease the level of confidence, then you increase or improve the precision of the interval. And the second way to improve precision is to increase the sample size. And so why is that? Why do these two methods improve the precision? It has to do with the formula for the margin of error. If you have a very small margin of error, that means that your confidence interval is going to be very precise. And if you look at this formula, if you have a large sample size, if your n is large, that will make this fraction smaller, and it will make your margin of error smaller. Also, if you have a smaller level of confidence, then your z-value is also going to be smaller. So if you have lower confidence, you'll lower the z, and your margin of error will also become smaller. This is an important note. You can never have high confidence and high precision at the same time. There's always a trade-off. If you want to have high precision, you might need to lower your confidence. And on the other hand, if you choose to have high confidence, your precision will decrease. And as a researcher, it's up to you on how you find that balance. Both are good. It's good to have high confidence, good to have high precision, but it's just not possible to have both of those maximized. So Part H says, suppose that prior to conducting the study, an economist at the Inland Empire Economic Partnership had hypothesized that fewer than 50% of households in San Bernardino County were multi-generational. Does the 99% confidence interval support this hypothesis? And why or why not? So, the confidence interval of 0.3578 and 0.4472, it does support this hypothesis. The interval indicates that the proportion of households are somewhere between 35% and 44%, and that's clearly all below 50%. So it's predicting that P is going to be below 50%. It's somewhere between 35 and 44. In Part I, it says, suppose that, prior to conducting this study, another economist at the Inland Empire Economic Partnership hypothesized that fewer than 40% of households in San Bernardino County were multi-generational. Does the 99% confidence interval support this hypothesis? And why or why not? This was the confidence interval, but this interval would not support this hypothesis, because from this interval it's not clear whether P is less than 40% or more than 40%. It could be less than 40%, but it's equally reasonable to conclude that P could be more than 40%. 40 is right in the middle, and it's just from this interval, it's not clear whether P would be above or below 40%. So, therefore, in this case, this interval would lead us to not be able to make any conclusion about this particular hypothesis. Part J, suppose that prior to conducting this study, a political scientist at the Inland Empire Economic Partnership hypothesized that more than 50% of households in San Bernardino County were multi-generational. does the 99% confidence interval support this hypothesis, and why or why not? Well, again, our confidence interval is from 0.35 to about 0.44, but this would not support that particular hypothesis. The hypothesis was that P is more than 50%. Our interval is showing clearly that P is less than 50%. And therefore, based on this confidence interval, we would have to reject this particular hypothesis.